Okay, so continuing on with quadratics, we're going to move on to finding the turning point of a certain equation. So there's a few different ways, and it's really up to preference if the question doesn't specify a method for you to use. So made familiar with these, and most of this would probably be revision at this point. So we can use the axis of symmetry, and the axis of symmetry means that you get an x coordinate for the turning point. And so what you would be doing afterwards is you would be subbing it into your function or your rule for y, and then you have your y coordinate as well. Alternatively, you can try to manipulate your expression on the right into turning point form. So to get it into this form, generally if you're going from standard form, you'll need to follow these few steps, and these few steps are what we call completing the square. So we're going to take a factor of a out first, so the coefficient of x squared, plus and minus by the square of half of the middle term, so b on 2a squared, then factorize the perfect square. It sounds a little bit complicated, but we'll walk through all of these processes and try to review what's going on. Of course, you can also use calculus, but we might leave that for another time since we're going to be doing a lot more of that later this year. Okay, so find the turning point for y is equal to 2x squared minus 4x plus 5. So method 1, we're going to use the axis of symmetry. Since if it's in standard form, using the axis of symmetry becomes very simple because it's really just plug into an equation and there you have it. Okay. So AOS, axis of symmetry. Our x value is going to equal to negative b on 2a. So negative b over here, the coefficient of x is negative 4 over 2a. So 2 times our coefficient of x squared, which is 2. Over here, we're going to end up with positive 4 when these two negatives come together. 4 on the bottom. And so we're going to end up with an x coordinate of 1 by turning point. Okay, so we're going to sub it in to our rule so we can find out what y is equal to as well. Now over here, when x is equal to 1, we have 2 times 1 squared minus 4 times 1 plus 5. Evaluating this gives us 2 minus 4 plus 5. This gives us 3, I believe. And so we just need to look at these two numbers. The axis of symmetry already gives us our x coordinate. Subbing it into our rule gives us our y coordinate. So our turning point, TP, is at 1, 0. Okay. Method 2. Okay, so we're going to be trying to complete the square here. So I'll start by writing out my equation, whatever is given to me. So in this case over here, it's in standard form. So right now, you always need the x squared to have a coefficient of 1 for completing the square to work. So we're going to take common factor of 2 out from this whole equation. So if you take 2 out, you're left with x squared inside. Taking 2 out of negative 4x gives you negative 2x. Taking 2 out of 5, it's not an integer, but if you have 5 on 2 times 2, you get 5 again. So we're going to leave that as 5 on 2. We divided everything inside, or everything from up here by 2 to get what's inside the bracket here. Okay, so from here, what you want to do is look at your x term. So generally it's in the middle. If you write it all in order, or well, polynomial order, then what happens is that you need x squared minus 2x, and you want to be adding and subtracting by half this number. So we're going to be adding by by 1 squared, so negative 1 over here. So let's say negative 1 all squared. So I just half negative 2 over here. So I'm going to be adding negative 1 squared. I'm going to be subtracting by negative 1 squared. And over here, the reason why we're doing this is 1. All of this is equal to 0. 2. If you're adding negative 1 squared or adding 1 over here, you'll see that we have a perfect square here. But let's just finish this line off. Plus 5 on 2. Okay. So over here, we can recognize that this is in perfect square form, or in other words, x minus 1 all squared is equal to x squared minus 2x plus 1. We know negative 1 squared is just positive 1. So if we turn all of this into this little expression over here, then y is going to end up equaling to u square brackets, or bigger brackets, doesn't matter, x minus 1 squared. We just compacted these three terms into this bracket squared over here. We also have minus 1 plus 5 on 2. We're just going to simplify this part. So negative 1 is 2 on 2. So we have plus 3 on 2. And now you can multiply the 2 into here to give you your k value of 20.4. So I'm going to leave the 2 outside the bracket over here. So don't distribute it inside your square bracket over here. And 3 over 2 times 2 is equal to 3. Ah, what do you know? This is exactly in turning point form, where this 2 over here is the a value, the h over here, it is just positive 1. Remember, the equation over here says negative h or minus h, so negative 1 means you have positive h, you have a positive 1 value for h, and k is a positive 3. Turning point is at h comma k, so it is at 1 comma 3. Okay, and those are the two methods. So one, you can use the axis of symmetry, sub it into your y value or your rule, and the other one is completing the square, and that's really useful when your equation is first in standard form.